this video we'll be solving a new Leetcode problem, and the problem is about linked list cycle. And we'll be given a linked list, and all we have to do is return a boolean value that returns true if the linked list has a cycle and false if linked list does not have a cycle. And that's the problem. It's simple enough. You can see in example 1, this linked list has a cycle. When you can see at the end, this node -4, it loops back to the second element. Therefore it has a cycle and the return output should be true. This also has a cycle, it should return true, but this particular node in an example 3 doesn't have a cycle and it has to return false. So the problem statement is quite simple, and we want to solve this problem in two different ways. The first one method is by using two pointer, and we also will be solving this using hashed method. So let's see the first method that uses two pointers, slow and fast. And you can see we're provided with the head of the linked list, and initially we have initialized both the slow and fast pointer to the head. And the idea is that I have a loop, and this loop, what we are doing is updating the slow pointer by one node and fast pointer by two nodes at a time. So you can see the condition to continue the loop is simply when slow is not finished, fast is not finished, and the next element in the fast is not none or hasn't finished. We're checking this because we want to find the next. If the fast dot next is none, then the next of none doesn't exist and we are going to have exception. And that's why we want to check if the fast dot next exists first or not. And that's why we have these three conditions to be satisfied to enter this loop. And inside this loop, as I said earlier, we are updating slow by one node and fast by two nodes, and checking if slow and fast are equal. If they are equal, then we are returning true that there is a cycle. And if this loop completes completely and still we don't see the slow and fast nodes to be equal, then we're returning false. Now, idea behind this is simple, that if there is a loop in a linked list, then at some point slow and fast pointer are going to be equal. Now I know this is hard to grab this concept, that how can slow and fast be the same at some point. Maybe we would have some sort of linked list where the slow and fast would never collide and still have a loop. But think of this way, like we want to think in the relative speed situation. Slow is running at let's say 10 miles per hour, and fast is running at 20 miles per hour. Now the relative speed between slow and fast is difference between their speed. In this case, that is 20 minus 10 miles per hour, which is 10 miles per hour again. Now in that relative speed perspective, slow pointer is stationary and the fast is moving at 10 miles per hour. Now if there is a loop, say for example in running, there's a track that has a loop, then if slow pointer is fixed and fast pointer is moving at 10 miles per hour, at some point in the loop they are going to be they are going to be in the same position, and therefore this condition is satisfied and we're returning true, right? And if in the whole linked list there is no loop, then the whole the linked list will terminate and therefore return false. That's the idea. So I could run this, it should pass all the test cases and do great. Yeah, it does, and I submitted it and it's great. It solves this problem in 50 milliseconds. That's okay. So that's the solution, right? Now I'm going to look at the second solution, which I'm going to copy and paste it. The second solution is even simpler than the previous one, and this uses hashing, or in this case we are using a set. So what we have done is initialized a set which we would call the node scene, which is empty set. And all we are doing is that you can see I have a loop here, and we are looping until the head is not none, or we have not reached the end of the linked list. And I think, yeah, we are updating the head. We are moving the nodes from one to the next in the linked list in this loop. And we also have a condition that if the current node, which is our head, is inside the set we have initialized, then it returns true, which means that this new head has already um, we have already seen this particular node in the linked list, and we are seeing it again, and in that case it's a loop, and therefore we are returning true. But if it's not seen, then what we are doing is adding this head inside this set, so that when the same head comes next time, we are satisfying this conditional statement. Then we are updating the head, and if the linked list terminates before we find the common node, then obviously there is no cycles, and then therefore we are returning false. Now let's run this again. This is one of the simplest solution, right? So let's see how it does. And yeah, it does similarly. The runtime is very similar, 53 milliseconds. So yeah, those are the two solutions for the problem of finding a cycle in the linked list. Thank you.